Good day, everyone. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today, we'll be looking at a CSEC additional mathematics question, all right, which is section 2 of the syllabus. That is the coordinate geometry, vectors, and trigonometry. All right, and the topic that we're focusing on is perpendicular vectors. All right, so here we have our question, which says the position vectors of 2 points, A and B, relative to a fixed origin O, are 3ti plus 2tj and 4i minus 2tj, respectively, where t is greater than 0. Find the value of t such that vector OA and vector OB are perpendicular. All right, perpendicular. Good. So another term that we normally use for perpendicular is orthogonal. All right, orthogonal. All right. So that's another term that we use for perpendicular. So let's look at the solution now. Okay, so we need to find out what is the vector OA and what is the vector OB. So I'm going to let the vector OA, all right, I'm going to let the vector OA be equal to 3t, 2t, and vector OB is going to be equal to 4, negative 2t. All right, I'm just writing the vectors in column vector form. So you ought to know that if I have a vector in the form of x, I plus yj, all right, where I and j are just unit vectors, that is equal to xy in column vector form, all right? Column vector form, all right? So that is what I did there. Good. Now it says we are to find the value of t such that vector OA and vector OB are perpendicular. Okay? So how do we do that now? We normally use the dot product, otherwise called the scalar product, also called the inner product of vectors. All right? So let us say I have two vectors, vector A, all right? Let me go over here. So vector A is equal to, let's say we have x, y, all right? And vector B is equal to p, q, then the dot product or the scalar product or the inner product of A and B is equal to xy dot pq. All right, so what we do here is just multiply the corresponding components and add them. So we'll multiply the x by the p plus multiply the q by the y, all right, or the y by the q, same thing. Okay, that is the dot product. Now, when you're doing the dot product, ensure to use this dot here as your notation, all right? Ensure to use that notation. Because if you use this notation, all right, vector A times vector B, that is something different, all right? That is actually called the cross product of vectors, which is not in the CSEC additional mathematics syllabus, okay? So do not use that notation. Always use the dot. All right, I hope that is clear for you. Okay, so let us now find the dot product of vector OA and vector OB. All right, so the vector OA dot vector OB, finding the dot product. So that's 3t, 2t dot 4, negative 2t. All right, negative 2t there. Okay, so let us now compute the dot product. So we're multiplying the corresponding components and then adding them up. So it's going to be 3t multiplied by 4 plus 2t multiplied by negative 2t. All right, that is the dot product. So this is now going to be equal to 3t times 4, that's going to be 12t, all right? And 2t multiplied by a negative 2t, I'm going to have a negative in front. 2 times 2, that's 4. T times t, that's t squared. All right, that is what I have. And this is the dot product of vector OA and vector OB. Good. Let's go back at the question. It says find the value of t such that vector OA and vector OB are perpendicular. What are perpendicular vectors? All right, so I'm going to use a fact here now. So if, all right, so if vectors are perpendicular, then their dot product, all right, then their dot product is equal to 0. All right, that's a fact. So if they tell you that the vectors are perpendicular, it means that the dot product of the vectors is equal to 0. So in order to solve for t here, that's what I want. In order to solve for t, I'm just going to equate the expression to 0. All right, so in other words, I'm saying that the 12t minus 4t squared is going to be equal to 0. Okay, and that is what I have. Now I need to solve this equation here for t. So in order to do that, I'm going to factorize the expression on the left-hand side of the equation. All right, so I realize that 4 is common in both terms and t is also common in both terms. So I'm going to factor out a 4t. When I factor out a 4t in brackets, I will have 3 minus t remaining, and that is equal to 0. All right, because if I have 12t and I divide it by 4t, I will get 3. And if I have a negative 4t squared and I'm dividing that by 4t, I will get a negative t. All right, and that product is equal to 0. Now, if 4t multiplied by 3 minus t is equal to 0, it means that either 4t is equal to 0 or 3 minus t is equal to 0. All right, that's what it means. So let us now solve the equations individually in order to find the value for t. So if 4t is equal to 0, I can get t by dividing both sides of the equation by 4. And if I do that, I will get t is equal to 0. All right? The other equation, 3 minus t is equal to 0. If I carry the negative t on the other side of the equation, I will get a positive t. So what I will get is 3 is equal to t, or t is equal to 3. All right, 3 equals t or t equals 3, same thing. Okay, those are my values for t. But let us go back to the question. The question said, find the value of t. All right, but remember here, it says where t must be greater than 0. All right, where t must be greater than 0. Let's go back to our solution now. So we said that either t is equal to 0 or t is equal to 3. Now the only value that is greater than 0 is this one here. All right, so it means that t is equal to 3 is going to be our solution. Let's write a statement here. So we're now going to say that since t must be greater than 0, it implies that the value of t is equal to 3. All right? And that is our solution. So remember, when we're dealing with perpendicular vectors, all right, or orthogonal vectors, orthogonal is another term for perpendicular, it means that the dot product must be equal to 0. Okay? That is what it means. That is what it means. So this is our solution to this perpendicular vectors question in the CSEC additional mathematics. All right, if this video was helpful for you, please ensure to like this video, subscribe to the channel for more upcoming videos, all right, and also share this video with your friends. I am Mr. Garth Reed, student ambassador in the University of Technology Jamaica and mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.